okay? I don't know what has gotten into you, where every single day you guys are a little bit more chatty and more ridiculous. It is time for algebra, not silliness. Although I do like to incorporate the silliness into the algebra, we can't just abandon algebra altogether and just do the silliness. Does that make sense? Can you guys adjust yourselves so that you act like algebra students and not zoo animals? Yeah? You can respond. Yes, Mrs. Legg. We will do our best impersonation of students who care about learning math, even if you have to pretend. Okay, so let's go over these. This is example 2, try it, from lesson 6.2. So we are gonna make our tables, and I see that some of you made your tables backwards, which is totally fine, especially because like the way that this is written, it almost kind of looks like a table. So it's okay if you did your table backwards and you kind of like shaded in that area, because as long as you are multiplying your terms correctly, you're fine, right? So 2x times 5x is what?
10x squared.
10x squared, because x times x is x squared. 4 times 5x is 20x. 2x times 2 is 4x. 4 times 2 is 8. So now we have to, we had notes on this yesterday. We multiply and then we combine like terms. And I think I said this yesterday, where I don't mind if you kind of put both of those steps in one, where you write it in standard form and combine like terms as you go. So when you write it in standard form, you have to start with the highest degree, which would be the 10x squared. And then we go to the next degree, which is the x terms, but since we can combine them, we'll just put that together as one term. And then we have our constant, and that's it. Easy, right? Same thing over here. Table looks a little weird, it's kind of smushed, but that's okay. 7x times 2x is
14x squared.
Good, 14x squared. 2 times 2x is
4x.
And 7x times 1 is
7x.
7x. 2 times 1 is
2.
Notice how anytime you're multiplying by 1, it's just the same all the way down, all the way across. Whenever you're multiplying by 1, just write the binomial over again. Then we circle our terms that can be combined. And then when we write it in standard form, we start with our highest degree. We combine the 4x and the 7x, and then we have our constant.
11x. Wait. Oh yeah.
Yeah, 7x plus 4x is 11x. Is there anybody who's still totally, or not totally, or is still having trouble understanding this? Everybody totally gets it? You got it, Angus? Good. All right, let's move on. Okay, so we're gonna do the exact same thing, but instead of using a table, we're gonna use the distributive property. So we're really accomplishing the exact same thing. We're just multiplying the binomials. After you do this, you might say, but I like the table method better. Great. Then even if it says distributive property, you can use your table method because you'll get the same answer, okay? So I'm going to teach you the distributive method for binomials, and then you can decide which one you like better. So we have 2x plus 4 times x minus 5. Now, when we distribute, we're used to just having one term and distributing it and drawing our arrows, right? We start the arrows from the same term, and it has like 2 branches. Now, if we have 2 terms to distribute, that's going to be a lot of arrows. Do you agree that, no, I haven't finished. Do you agree that if this entire expression is being multiplied by this entire expression, then I'm going to need to distribute the 2x to this whole thing and the 4 to this whole thing. So I would have to distribute the 2x to this and to that, and I'll also have to distribute the 4 to the x and the 4 to the -5. That's a lot of arrows. It might look a little complicated, so if you want to kind of map it out a little bit clearer, we're simply going to take our 2x and our 4.
Isn't that the FOIL method?
It's not the FOIL method. The FOIL method is where you do the first. Oh yeah, I guess it is the FOIL method. But they don't call it the FOIL method yet. I think they're going to introduce the FOIL method later. I talk about the FOIL method in the topic 6 readiness corrections guided notes. So raise your hand if you've heard of the FOIL method before, besides Jeff. Never? You guys didn't do the FOIL method at all last year? You didn't multiply binomials at all? Raise your hand if you heard about the FOIL method because you actually read my topic 6 readiness correction guided notes. Only a few of you. Thank you for the few that did read the notes. How could you do the readiness corrections if you didn't read through my notes?
I read through the notes, I just didn't.
You don't?
I just don't know what the FOIL method is.
Yes, Vincent?
Oh.
Yes.
I know what it is.
Great. So the distributive property, yes, it is the FOIL method, but we're not using the word FOIL at this point, although it is the same thing. What we're gonna do is we're gonna split up our binomial so that the 2x is distributed to this, 2x is distributed to the x minus 5, and the 4x, I'm not 4x, the 4. So my positive 4 is distributed to the x minus 5. Do you see how both terms from the first binomial are distributed to the second binomial? Okay. Now the arrows will be a little bit clearer, so when I distribute, I can kind of go from left to right instead of all over the place. And then we'll just distribute. So we have 2x times x is, you guys just shout it out, 2x squared. And then 2x times -5 is? Negative 10x. I'll change color, just I'm doing my other term here. And then I have my 4 times x is? 4x, so I put a positive 4x. And then 4 times -5 is?
-20.
-20. What do I do next? Yep, combine my like terms. So I'm just gonna rewrite it. It's already in standard form, which is great. So I have my 2x squared minus 6x minus 20, and that's it. Yeah. Right, so when I introduced this example, I said the table method works for this. I said I'm gonna teach you a different method and then you can decide which one you like better. So I'm not mad about it, but keep in mind that you did the table method again and you didn't learn the distributive property. So now you won't give yourself a choice because you only know one. Okay, so next time when I say I'm gonna teach you both and then you can choose, learn both of them first and then choose. So I want you to use the distributive property for these, okay? I will leave this up. So my original problem was 2x plus 4 times x minus 5. You should also have this in your notes, so I will leave that up so you can kind of see it. And then we're going to use the distributive property for these. I will write the steps to solving it. Steps for multiplying binomials using distributive property. Okay, so step 1 is split up the terms of the first binomial and distribute each one to the other binomial. Split up the terms of the first binomial and distribute them to the second binomial. Distribute each one to the other binomial. Step 2 is algebraic multiply. Step 3 is combine like terms. And step 4 is standard form. And you can do those at the same time if you want. Are you guys ready for me to come around?
I'm on some.
I see some hands. Are you ready? Are you help? Okay. So did you copy down the? Okay. Yeah, well, 10 is squared because the x times x is 10. Perfect. Yes. What do you need? Oh, you like some wax. Your body. I have to move your mouth. Looks great. Something wrong with these. So you did not follow the steps. So I can't see your work because you didn't follow the steps. These two are not. You stinky baby sniffer. No, and you're also not following the steps. Hey guys, if I separate my terms and distribute them, you separate your terms and distribute them. If I write split up the terms of the first binomial and distribute each one to the other binomial, you split up the terms of their. So you guys are going, did I do this right? No, you didn't, because you're not following my steps, and I can't even tell where you went wrong because you're doing it in your head. And that's a very scary place. Please don't try to take me there, okay? Please show all your work, and then I'll be able to point out where you went wrong, instead of just saying, no, you did it wrong because you didn't follow directions. It sounds very mean. I don't like being mean. I like being nice. What am I looking at right now? Is that a minus? Yeah, that's
Yeah.
Yeah, that's good. Oh wait, you're just gonna say the next one.
Oh.
That's great. Okay. Something's wrong. So this would be 10x squared. And then this would be 5x. Just go through it again because there's like a couple of things wrong. I'm just gonna go around. So this would be 10x squared because it's 5x squared. And it says, why does it say in the negative? Yeah, negative. Yeah, you can keep the whole binomial in front of you. Yeah, just like I did up here. And I have my example right there. Great. And this is, these two are not right. That's good. Oh, wait, no, this is correct. I'm sorry. This is so 20. Is you do 25.
Oh, sorry. My bad. I did good.
Yeah, you did great. Okay, you did it?
Yeah, I was thinking over not right.
Okay. How am I supposed to get by with that ridiculous
Yeah, Jacob!
What do you mean?
thing?
I literally followed every step.
Okay.
Come on, Jacob.
I'm so
Be
happy.
better.
Unfortunately,
I'm not the one.
I'm worried for your small petite brain.
so you didn't set it up correctly. So it says to split up the terms of the first binomial. So there's the first binomial. Split up these terms. So you have a 5x, and then the negative 4 is in here. Split them up, and then use this. Yeah, you use this as the other binomial. You're really close. It's just supposed to be 10x squared because x times x is x squared.
Oh, that's why it's square.
Hey guys, I know you love when I come over and give you the individual attention, and I try to do that as much as I possibly can, but please know, if I don't get to you, it's not because I'm only getting to the people who I care about and the rest I don't care about. I care about every single one, and you know I wish this class would go a lot longer so I could actually teach you more and more and more. But I have to get to the next thing. You can sharpen. Because I have to move on, I have to only go to a certain extent. Then I come to the board and I go through the whole thing so everybody gets the instruction, okay? So please just be patient with me. If you're like, oh, she never came to me, it's because I spend some time walking around and then I just come to the board and I don't say, forget it, if you don't know, you don't know, and let's go to the next thing. I will do it on the board, but you guys have to pay attention, okay, if I didn't come to you. Now, we're gonna do the same thing. We're gonna do split C's, split up. Sorry, I had my fingers on the wrong ones. We're gonna split up our first binomial. That's what it says right here. Split up the terms of the first binomial. Here's the first binomial. These terms are going to go split C's, okay? So we'll have 5x, and then I'll have a negative 4. Then, distribute each one to the other binomial. Here's the other binomial. I have to distribute the 5x to this binomial and distribute the negative 4 to that binomial. So I simply show my arrows now and I multiply. 5x times 2x, a lot of you guys wrote 10x. It's very confusing because if you were adding the x terms, it would just be x. But since we're multiplying, x times x is x squared. A way that I can kind of explain that would make more sense than it already does, is if you are finding perimeter, I'll use 5 and 2 as an example. I'll use 5x and 2x, okay? If you're finding perimeter, actually, I'm gonna use even simpler things. I'm gonna say 5 inches and 2 inches, okay? If we're finding perimeter, we would add up all the sides. I would have 5 inches plus 5 inches plus 2 inches plus 2 inches, right? And what would I get?
12.
The perimeter would be what?
14.
Nope.
Yeah, what? 5 plus 5 is 14.
10.
You're right. 5 plus 5 plus 2 plus 2 is 14. But what is the perimeter? Who said that? 14 inches, thank you. And the reason I'm being nitpicky about that is the whole point of this example is to show you that when you are adding, it just stays inches, or it just stays x. You don't do anything with the exponents, you just use it as a label. Now, if I asked for the area, we would multiply 5 inches times 2 inches, and we would get, what?
10 inches squared.
Thank you. You guys are really missing the point of this example. 10 inches squared, because it would be 5 inches times 2 inches. 5 times 2 is 10, inches times inches is inches squared. You know why? Because it actually makes squares. Well, those look like rectangles because my drawing is terrible. But that's why we call it 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 square inches. That's why we call it squared. Do you guys get that? So that was my little mini lesson on why x times x will give you x squared. The other mini lesson is when you think about it, x times x is x times itself, right? And we represent something being multiplied times itself as being squared.
Can you also write, sorry.
It's okay, go ahead.
Can you also write 2x?
No,
Why not?
What's that?
you can't write 2x. Okay, I'll give you the reason why you can't write 2x. Let's say that x has a value. Give me an easy value for x.
2.
I'm gonna take 3 because 2 is annoying. Because 2 times 2 is the same thing as 2 plus 2, so it won't work. Okay, so let's say x is 3. 3 times 3 equals 3 squared, right? Which equals 9. If you're telling me that I can just do 2x, then you're saying that 3 times 3 could also be written as 2 times 3. 3 times 3 is 9. 2 times 3 is 6. So 3 times 3 is not the same thing as 2 times, is having 3 2 times. 3 plus 3 is having 3 twice. So if this was x plus x, x plus x is 2x. X times x is x squared. This is so important, okay? I don't mind spending an extra minute on this because if you guys don't get this by now, do not ask me to go to the bathroom. Every time you ask me to go to the bathroom, you're telling me my class is not important.
Can I use my phone?
You can go pee at home, okay? In my class, we do algebra. Then go when the period's over, in like 10 minutes, okay?
But I only have 3 minutes, don't have time.
Tell that to your next teacher. Another problem. I'm kidding. Can I get back to teaching? Thank you. Let's do the other example now. Did we even finish that?
No. The only way is x squared.
5x times 2x plus 1 minus 4 times 2x plus 1. Distribute. 5x times 2x is?
10x squared.
Did you say 10x again? Okay, it was a little delayed. 10x squared. 5x times 1 is?
7x.
5x.
I don't have to count.
Negative 4 times 2x is what, Lily?
Negative 4 times 2x.
Negative 4 times 2x.
Is...
You don't have to look at your note, you can just say it. Negative 4, we're distributing. Boop. Boop. Negative 4 times 2x is what? Yeah, negative 8x, very good. And Alea, negative 4 times 1 is? Negative 4 times 1. Very good, because negative, anything times 1 is itself, right? Okay, are we done?
No.
Combine the like terms.
Ugly now, stupid.
So we have 10x squared minus 3x, because that's what 5 plus 8 is, and minus 4, that's it. I'm gonna move on. Do you guys completely understand this? This is the exact same process. So if you're confused about this one, do what we just did, okay? Does anybody want me to read the answer for B? Yes? For B, it's 14x squared plus 11x plus 2.
Yeah,
Okay. What?
Where'd you get the 14?
Well, we just went over the other one in detail, so can you try that one again? You can probably find your mistake if you. So a positive 12. Where's your x?
Huh?
Negative 5 times 2x is negative 10x.
Then mountain is like right here in bold.
So sometimes like little mistakes like that can cause like the whole thing to be wrong in the end. I don't know if I've already said this in this class today, but I think I did, but you guys have to make sure that, especially with this kind of topic where it has so many terms, you're probably gonna get a lot of answers wrong on your tests and quizzes. But if you show your work and you can show me in the end that it was just a silly mistake and you like added wrong and then it turned the whole thing wrong, but you show me your process is totally right, I will give you full credit. Stop. Okay, now we're back to tables. Because tables and the distributive property do the same thing, just in different ways. You can use tables for even trinomials. You just gotta make your little tic-tac-toe board bigger. You need 3 sticks at the top. And then we'll put our trinomial, I'm just gonna cross that out there. We're gonna put our trinomial up at the top, even though it doesn't really matter. If you want your trinomial down here and your binomial up there, that's totally fine. Boys, can you stop? Thank you. X squared, 2x, and negative 1. All I did was took my trinomial, split up my terms into their boxes.
Oh.
Gonna take my binomial, do the same thing. I've got a 3x and a 4. And then we just multiply. 3x times x squared is what?
3x squared.
Nope.
What was it?
Yep, 3x cubed. 3x times 2x is
5x cubed.
6.
No, wait, my mind.
X.
My brain went to
Cube.
add it.
6x cubed.
X times x
Squared.
is x squared. 3x times negative 1 is negative 3x. 4 times x squared, 4x squared. 4 times 2x,
8x.
good. And 4 times negative 1,
Negative 4.
negative 4. Now we're just going to take a look at our terms, see if anything is alike. I've got a 4x squared and another x squared term here. And I've got an x term and an x term. So I've got 2 pairs that can be combined, not all together, but separately. I start with my highest degree, which is my x cubed. And then I go down to my x squareds, and I can combine those to get positive 10x squared, 4 and 6. And then I can combine my x terms to get positive 5x, and then I just have my constant. That's it. So the process for this is the exact same process that we used for the table for binomials. You just have an extra row.
Yes.
Do that. We are not gonna, we might. If we don't get to the last example, Please know that the very end of the homework help video goes through it for your homework. So if you need help on your homework,
Next slide. Yeah.
I would highly recommend doing the table, but you want to do the distributive property?
Can I shock myself?
2 times.
Can I get me some candy if I get it right? If I get one right?
No, because then everybody else is going to want to do that, and nobody's going to learn the table method. Bo, can you stop, please? I didn't ask for any kind of explanation. I just asked you to stop. On your canvas? Keep in mind that Canvas and Savvis are still not connecting on my end, so I have to make your homeworks in Savvis. I think 6.1 is in Canvas, but 6.2 is in Savvis. And I know you guys can't just like get to Savvis unless you go through Canvas. So what do you have to do? Click on a random assignment in Canvas, click on the Savvis button, and then find 6.2. So if you go to Savvis, you go to Canvas, you're like, I can't find the homework. Click on a random button, a random assignment, click on the Savvis button, and find 6.2. I did, and then something went wrong, and I'm still trying to work with IT to get them connected again. But for now, I can only
Can you write this step
Sure. I think, aren't the steps there in your notes yesterday when I did the table for the binomials?
Yes.
You can use the same steps. Only the first one is wrong. And that's the kind of thing, like, if you got it wrong on the test and showed me this whole thing, I could give you full credit for it. I got it. What does it say? Okay, yep. You want me to check? That should be under the negative score. Because these are negative. Look, -7 makes this a -14. -5 is a Do you guys hear yourselves? Is it supposed to be chatty or silent right now? Silent is the answer. This is, no, it's not right, like at all. Nothing about it is right. We do the table method. You got it?
Yeah. Sorry for being late.
That's okay. I know that you have to. This is not right, but everything else. Good. Great.
No way, I'm so done. Alright, who said this?
Yeah. This? This is not right. Why didn't you do the table?
So what do you do?
We're supposed to be doing the table.
Yeah. You got better than me then. Yeah.
Good luck.
Yeah.
I got one for you.
Can you get it right?
Negative times a negative.
What'd you It's a 4.
The last term is right. That's good.
Good luck.
So that's what we're going to This is A? Oh no, this is B, okay. Very good. Good, okay. I'm gonna go over them. Did you guys get it?
I just wanted to see or not.
A. Yes. Yes. All right. Raise your hand if you did not get A right or you didn't finish it. Okay, so what? A, just
Oh, just
A.
A?
Yeah, but there are a good number of people who still need me to go over this. So I'm going to make my tic-tac-toe board and fill in my trinomial. Doesn't matter if the trinomial goes on top or not. 2x minus 5. So then we multiply and we get what? 2x times negative 3x squared is?
Negative 6x cubed.
Good, negative 6x cubed. 2x times 4x is?
8x squared.
8x squared. 2x times negative 7 is?
Negative 14x.
Good. Negative 5 times negative 3x squared is?
Negative 15x squared.
Nope.
15x squared.
15x squared. Negative 5 times 4x is?
Negative 20x.
Good. Negative 5 times negative 7 is?
35.
35. Then we just take a look and see what terms can be combined. Those can be combined, and those can be combined. So we get negative 6x cubed plus 23x squared. And then minus 34x plus 35. Does that make sense now? Okay. Let's do the next one. Raise your hand if you did not get B right or didn't check it yet. Okay. So we're going to make a table. 2x squared, 3x, and negative 4. It's important to have your terms with their signs. Negative 3x squared and 1. Hey, I love when there's a positive 1 because that means that this whole row is this row. 2x squared, 3x, and negative 4 because they're all being multiplied times 1. So they stay the same. Up here we have?
Negative 6x to the power of 4.
Good. Then we have?
Negative 9x to the third.
Yep, cubed. And then we have? 12x squared. Raise your hand if you found your mistake already. Angus, what did you get for this? For B? You didn't start it?
You did A. You did A.
Did you get it right?
You did it. Did you get it? You did it.
But I just went over A. Did you see if you got it right? You gotta pay attention at this, okay? So let's, A this can't be combined with anything, and this can't be combined with anything, only these two can be combined, that's gonna be a really long answer. I've got my negative 6x to the fourth minus 9x to the third. Oh, combine these and I get plus 14x to the second plus 3x and minus 4. That's the whole answer. What are the chances that even if you understand this, you're gonna get this right on a test? Not good, because guess what? I make mistakes on this stuff all the time, because it's a lot of stuff. So, show all your work so that you can get the credit when you get it marked wrong on the digital answer page, okay? I don't have time to go over the last example, but you need it for the homework. So you can just do the homework along with me on my homework help video tonight. It's due tomorrow. 8 questions.
Yes.